Technical controls come in three main types: preventative, detective, or corrective. Up until now, we've only considered preventative controls, but no control can prevent every type of attack. So beyond preventative controls, we also need controls that detect and correct. Two such controls are called intrusion detection systems and intrusion prevention systems. In some ways, intrusion detection and intrusion prevention systems are similar to firewalls. Similar to firewalls, intrusion detection and prevention systems both inspect packets. They also look at things like source and destination addresses. They examine port numbers, inspect session ID numbers, and other control signals that manage end-to-end communication. The most sophisticated intrusion detection or prevention systems also feature deep packet inspection. All of this is similar to what firewalls do. Packets are inspected at one or more network layers. Depending on the set of rules guiding the inspection, decisions will occur about how to process the packets. Where intrusion detection and intrusion prevention systems differ from firewalls is in the complexity of the processing decisions. When firewalls catch a suspicious packet, they just drop it. Intrusion detection and intrusion prevention systems have other ways to handle suspicious packets beyond dropping them. Let's start by considering the goals of intrusion detection. Like the name says, the main purpose of intrusion detection is to note that an attack has happened. Intrusion detection systems are designed to create a record of traffic that may indicate a break-in. In a pure intrusion detection system, suspicious packets are not designed to be dropped. Instead, the packets will be allowed to pass, but an information-only response will occur. This informational response will be more or less active depending on how the intrusion detection system has been configured. The most passive sort of intrusion detection just creates log file entries. Log files are much needed, especially for detecting long-term or slowly developing threats. However, just logging a possible attack is a very quiet approach that may not get any notice from system managers. A more actively configured intrusion detection system will send an alert to a system administrator. Such alerts may come in the form of a blinking light on a management console, or the alert could set off a pager or ring an alarm. In this way, intrusion detection systems might be compared with items ranging from security cameras to burglar alarms, depending on the aggressiveness of their alerts. Intrusion prevention systems do more than set off alarms. These systems act dynamically to shut down channels of potential network attacks. Intrusion prevention systems work hand in hand with firewalls to block any suspicious traffic flow. Where intrusion prevention systems differ from pure firewalls is in their dynamic nature. Intrusion prevention systems respond to suspicious packets by creating new rules for the firewalls they work with. For example, suppose a stream of suspicious traffic is detected coming from a particular range of IP addresses. An intrusion prevention system can create a new firewall rule to block that range of inbound addresses. It can also activate the new rule automatically, with or without alerting a human manager to the policy change. There is a family relationship between firewalls, intrusion detection, and intrusion prevention systems. They all inspect packets. Where they differ is how they respond to suspicious activity. Firewalls block, intrusion detection logs or alerts, intrusion prevention sets up new rules. Also, many recent defensive systems combine several of these features within a single appliance or software package. Many firewalls, for example, are likely to advertise intrusion detection or prevention as part of their overall feature set. The distinction between firewalls, intrusion detection, and intrusion prevention is more conceptual than practical. In actual network security systems, you can see all of these features combined with each other and with other types of technical controls. Intrusion prevention systems are best positioned at the edge of a network where they can inspect all of the inbound traffic. Intrusion detection systems present more options with respect to where they may reside. Putting intrusion detection on the network edge is one possibility. However, a good case can be made for installing intrusion detection far deeper on a local network, well behind the perimeter firewall. The network perimeter is noisy. A network edge device is going to get probed all the time by packets that may be part of an attack. It might be worthwhile to log all this malicious traffic, but beyond just capturing data about the many sweeps and scans that will test any network connected to the internet, more aggressive alerting from the edge is likely to be more trouble than it's worth. It's kind of like car alarms that go off in parking lots when anyone comes near. Such alarms go off so often that people just tune them out. Similarly, an intrusion detection system at the edge of the network will be in such a constant state of alert that none of its reports or advisories will really carry much weight. So putting intrusion detection deeper in the network may be the better approach. In general, there are two ways to do this. One is called host-based intrusion detection. The other is called network-based intrusion detection. Host-based intrusion detection systems reside on a single host and only filter traffic bound for that host. Network-based intrusion detection systems capture traffic across an entire network segment and identify threats traversing the network. In general, it makes the most sense to place host-based intrusion detection on high-value assets like servers. Likewise, network-based intrusion detection will do the most good if it monitors traffic in the near vicinity of such high-value assets. Filtering rules for intrusion detection or prevention come in two basic types. One type is called signature-based. The other is anomaly-based. Each type of intrusion inspection has its own characteristic strengths and weaknesses. Signature-based intrusion detection systems rely on a database of known attack signatures that must periodically be updated. Signature-based intrusion detection excels at identifying well-known attack patterns. Anomaly-based intrusion detection systems, by contrast, compare current traffic to a known baseline and signal an incident when traffic exceeds typical parameters. If an attack has not been recorded and publicized by the security industry, an anomaly-based system may be able to catch it anyway. Such previously unknown attacks are known as zero-day attacks. Signature-based systems generally will miss zero-day attacks. But anomaly-based systems are not assured of recognizing zero-day attacks either. It depends on how the specific attack works, and it also depends on what kind of baseline network traffic the anomaly-based system has become used to seeing. A problem facing all forms of intrusion inspection is to avoid false positives and false negatives. A false positive is an alert on traffic that is in fact benign. A false negative is a failure to identify traffic that is in fact a threat. Signature-based intrusion detection will limit false positives because it needs to recognize a known attack pattern in order to sound an alert. However, signature-based systems will also be prone to false negatives because if an attack differs even slightly from previous patterns, it may well slip in unannounced. Anomaly-based intrusion detection will have better chances of avoiding false negatives on zero-day attacks. That's because anomaly-based systems consider dynamic behavior, not just a static signature. However, because anomaly-based systems are not precisely targeted on the known attack patterns, the chances for false positives will also increase with these systems. A honeypot is a very special kind of intrusion detection system. A honeypot is essentially a trap that is set for intruders to fall into. Honeypots are disguised to look as if they carry valuable data. An intruder who penetrates the network should see the honeypot and try to take possession of it. When such attempts occur, all of the intruder's actions are logged and analyzed. This provides valuable insight into what the intruder is trying to accomplish and which attacking techniques are being used. A more long-term approach to intrusion detection is Security Information and Event Management, or SIEM. The acronym SIEM is a composite of two related ideas: Security Information Management, SIM, and Security Event Management, SEM. Although distinctions between these three concepts are not well defined, in general, SIEM and related systems strive to automate both the analytic and the response processes for security-significant occurrences on networks. Some common characteristics of SIEM include centralized logging, automated log analysis, correlation of disparate events, incident alerting or response, and reporting. SIEM fits somewhere on the same spectrum as intrusion detection systems or intrusion prevention systems, although with SIEM there is a heavier emphasis on analytics and reporting. Of the technologies we examined this time, most of them would be considered detective controls. Firewalls and intrusion prevention also have a preventative side to them. But intrusion detection, including honeypots, is really all about detection. So is SIEM. In the best case, attacks will be prevented by the different defenses that are deployed. In the next best case, attacks not prevented will quickly be detected. And in worst case scenarios, no matter whether attacks are found out sooner or much later, these attacks will need to be corrected. When a successful attack has been identified, the attack will now be classified as a security incident. Incidents call for an incident response. Incident response is our topic for next time.